Okay, question 3, and we start with the definition. Define the term free fall, another 2 marks. The motion during which the only force acting is gravitational force. And you need to have the underlined words, otherwise you're going to lose the mark. And it says 2 or 0. So if you're missing any of those words, you get 0, which is quite harsh, but it's not a difficult definition. You just need to, I don't know, read them a lot or something. And if we can just check here quickly, I may be doing this in the incorrect order now, but just as a thing, 3.4, 3.4, 15, 15. The numbers in the question are written on the picture, and so we should then be okay with the question. If a problem comes up though, you might actually need to read it properly and carefully. So now, for 3.2, they ask you, was the ball in free fall between T1 and T2? T1 and T2 is when it's bouncing. I don't know whether you know that, but it says here it's after the first bounce. When T1 and T2 is when it's bouncing. Basically, you should actually draw this graph the other way around, like this, if you want to see more or less what's happening. And this would be up is positive. Here, down is positive. Because the gradient of a position time graph, so the gradient of this graph is velocity. And the gradient of this graph is positive. This is a positive gradient. So for this red piece, it's moving down. And for this other piece, for this blue piece, it's moving up. Because the gradient of the red piece is positive. The gradient of this is positive. And the gradient of this is negative. So if you turn it around, it maybe looks a bit more logical, like what's happening. And so, was it in free fall while it was on the ground? No, because it was not only being acted upon by gravitational force. Okay, so now, for projectile, you always end up with more than one option. I would like us to go with the downwards as positive option, only because that's what the graph said. But obviously you can do either one. So I would make downwards positive, because the graph is making downwards positive. So I'm just going to show downwards as positive answers. Your equations of motion have 4 numbers in them. I need you to get me 3 numbers. So we need 3 numbers for this red piece over here. We need 3 numbers. And we are going to say, or I'm going to say, that down is positive. We need 3 numbers. We always have that the acceleration is 9,8, and in this case it's downwards. We have that the VI is 3,4, and that is also downwards, because it says in the question it's a constant vertically downwards at a constant velocity of 3.4. Then we need another number. The displacement is 15 meters, and that is also downwards. So now this is maybe confusing, because this says minus 15, but that's because the balloon is 15 meters up. But the ball goes from the balloon to the ground. The ball's displacement is 15 meters downwards. So the delta y or delta x for the ball is 15. And if you sub those numbers in, see here, you get 3 marks, formula, substitution, answer. And that wasn't that difficult. The rule is, for projectile, you need 3 numbers. 3 numbers for a relevant piece of what they're talking about. So for 3.3.1, they're talking about this little red piece here. I need 3 numbers for that piece, and that's what I got, and so I can get the answer. Then for the next one, they want the height of the hot air balloon above the ground at the instant when the ball struck the ground. Now, if you can see here, this is 4 marks. It's not just 3. It's not just FSA. You've got to do a bit more than just FSA. So, again, they want to know about the height of the hot air balloon when the ball hit the ground. So now I need 3 numbers for what's happened in order to use an equation of motion. But the ball struck the ground at T1, which is 1.44 seconds. How high is the balloon at 1.44 seconds after this situation happened? So if I can just move that away. Sorry. Oh, sherbet. Sorry. Okay, so the height of the hot air balloon above the ground at the instant when the ball struck the ground. So the hot air balloon is moving downwards at a constant velocity for 1.44 seconds. You can just do speed, distance, time as well if you prefer. I can't see without. Oh, they told you to use equations of motion. But basically this example here, they're using speed, distance, time. But they're also using upwards as positive. I would like to use downwards as positive. So if we use the downwards as positive one, oh, come on, Terry. If we use the downwards as positive one and we get 3 numbers, the V of the balloon is a constant 3.4 downwards. So the velocity of the balloon is a constant 3.4 downwards, and the movement is happening for 1.44 seconds. It did tell you to use equations of motion, so I think that they only started accepting this option 3 later on. But anyway, if you have to use equations of motion, we always need 3 numbers. The velocity is 3.4 downwards, a constant velocity of 3.4 downwards. We know that because it says so in the question. So we know that the VI is 3.44. We know that the acceleration is 0 because it's a constant velocity. So acceleration is 0. And we know that the time is just simply our answer from the previous question. So it helps with this section to always get an answer, because 3.3.1, 3.3.2, 3.3.3, 3.3.4, you're going to use previous answers to get answers in the future. And often they ask you to draw a graph. And if you need to draw a graph, you need to draw your values on the graph. So it really would help in this instance to just get an answer. Just keep trying until you get some sort of answer which you can use to do your graphs and things. Oh, sorry, I don't need that one. Okay, I think the other one was down here somewhere. Oh gosh, okay, sorry. Where was that other one now? There it is. Okay, so 3.3.2, 3.4. Okay, so now they want T3. So for this question, you didn't actually get asked to do a graph, but if you do any other examples, you may or may not end up with a graph. I'm just going to try and cover this because it's a bit too much to deal with. But this last one is 4 marks. So again, it's going to be more than just FSA. They say the ball was in contact with the ground for 0.2 seconds and left the ground with a vertical upward velocity of 7.2 meters per second. You are only allowed to use equations of motion to calculate the value of T3. So what they are saying is you need to get 3 numbers for this piece of movement. 3 numbers for that piece of movement, and A is going to be 9.8 downwards, as always. I would like down to be positive. The VI is 7.2 upwards, so in this case it would be negative 7.2, and the VF is going to be 0 because it always stops at the top. So they want the value of T3, which is the maximum height after the bounce. And they tell you on here, I think, until it reaches its maximum height after the first bounce. So T3 is the maximum height after the first bounce, and at the maximum height, the velocity is always 0. We have 3 numbers, so we can work out any other number. So now, if I just uncover this quickly, where's the down positive? Okay, so I would do it, I like to try and be consistent with what I'm doing, believe it or not. And so if we can get 3 numbers, we can work out any other number. So for this green piece, these 3 numbers apply. So I use these 3 numbers to work out the time. I work out the time that it takes for this little green bit. Then I add the answer from this one, because that's the red bit, and I add this time here, because that is, let me just color it in a different color, that little blue bit, because they told you it was on the ground for that time. So the red plus the blue plus the green together makes 2.37 seconds. And that's how you get those 4 marks. This question, direction is incredibly important. So if you say up is positive, please commit to up being positive. Or vice versa, if you say down is positive, please commit for the entire time for down being positive. Be very careful if the question tells you what direction you must do. And drawing the graphs, you need to look at doing that as well, because even if you just plot the points and draw any sort of line, you can get marks. A position time graph, the lines are going to look like this. A velocity time graph, they're going to be straight lines, always. So this question, I think we can also get more than 10 if we just 3 numbers, pick a formula, put numbers in the formula. You'll get those 2 marks. So we obviously studied our definitions. That's 2. This would maybe be a guess. Let's not give it to us. Formula and substitution would be 2. Formula and substitution would be 2. Formula and substitution would be 2. So that means we got 2, 4, 6, 8 marks for this question with getting this one wrong and just studying our definitions. Yeah, sorry, that's maybe not over 10, but 8 out of 14 is still more than 50%. So maybe if not more than 10, we can at least get 8 out of 14.